All right. Good morning, everybody. Welcome back to Comp 2450 Software Development 1. I don't know about all of you, but I'm feeling pretty good this morning. It was sunny today. I don't know where everybody's from. I don't know where everybody's lives, but I don't think that I could live in a place like Vancouver, and I don't think I could live in a place like on the East Coast, because after like 2 days of rain, I'm just like, wow, I don't want to feel that anymore. I don't want rain anymore. And so this morning when I was biking here to work, it was just like, yes, it's finally sunny. There's not much wind. It's still quite humid, but you know what? I'm counting this as a win, and I'm really just happy. I'm feeling good about that. I hope that you have all had a great weekend despite the weather. Today, what I want to do in class is spend a little bit of time continuing what we've been working on so far in the course. The topic is going to change slightly today. What I want to do today is talk to you a little bit about generic interfaces. So you've seen and used generic interfaces before. I want to show you what a generic interface looks like from the perspective of having created one. I'm not going to do this as a live coding exercise today. I really just want to show you what it looks like for a generic interface to be in your code base. I'll step through some parts of this. And then what I do want to do is I want to run this example in my debugger and start to think about things like practical visualization of things like composite and aggregate relationships of types. So if you want to follow along with the debugging, if you want to see the code that I've got for this on a smaller screen in front of your face as opposed to on the big screen up here, I've put a link to a Git repository in today's lecture that's called 2450 Stack. That's the thing that we're going to be working with for this. Then what I want to do is I want you to be able to explain why the toString method is not an appropriate tool for displaying information to people. This is me going to be kind of just preaching at you. I'm just going to tell you about why I don't think this is a good idea, and I'm going to try to give you some concrete examples of why I don't think that this is a good idea. This is a pretty typical thing for you to use in a course like Comp 1020, but as we move forward and as we start to have other people using our software, it's going to become less and less appropriate for us to use something like toString for displaying information. So like doing system.out.println class name.toString. This is specifically what I'm thinking about here. I want to tell you about this, and I want you to be able to think about why this is the case. And then the last thing I want to do, and the one that I'm the most excited about for today, which is the idea that I want to start thinking about these things called invariants. And I want to start thinking about this idea called design by contract. Design by contract is this really cool idea where it really doesn't have anything to do with Java. It doesn't have anything to do with any specific programming language. And it's very much about taking the stuff that we're thinking about in terms of the valid properties of an instance of an object and starting to actually encode those things in the code that we're writing. And really, it's to help us and it's to help other people who are using our code, not our parents, but other programmers, other software developers that are using our code. And so I want to start thinking about this in terms of taking some of the classes that we've been defining and then explicitly stating what these invariants are for those classes. So what are the valid values of properties that we can have in a class? So generics. As I said before last week, generics really is this idea that I want to be able to pass a type to another type as a parameter. I want to be able to tell something that it is going to have instances of this thing in it at compile time. And the way that you've seen this before is with collections in Comp 1020. So this is where you were using that array list type. Generally, though, this is some kind of composition. It's not necessary for it to be a collection of things. It can just be one instance of that thing, but it's some kind of composition or aggregation relationship between these two types. So the place where you might have seen something like this before is to say something like a list of strings that has a name of names that's filled with names is assigned to this array list type. The generic part of this is using these angle brackets here. So list here, this is an interface that's been defined for a list abstract data type or data structure. String is basically saying here, I want this to be a list of strings. ArrayList itself is an implementation of the list interface, and it also has this diamond. It also has these angle brackets here. Java has this nice feature that we can just put these diamonds, these angle brackets right next to each other, and it figures out what's supposed to go on that side. What I would like us to do right now is to take a look at an interface for a stack, and I want us to take a look at a couple of implementations of that, or at least one implementation of that generic interface. And like I said, I want to step through the use of this thing to try and illustrate some of the ideas of what happens when we have these composite relationships in practice. So I'm going to pop over to my IntelliJ here. So like I said, this is a repository that I put linked to up on the course webpage. This is the stack repository. And what I'm looking at right now is the generic interface that I've defined for a stack. The first step to making this a generic interface is to declare it as a regular interface, and then immediately after the type name, use these angle brackets. I've used the letter T here to indicate that this is the name of the type that's going to be put into this interface when I declare an instance of this thing, when I actually make an instance of this thing. In every place where I want to use the type that is being passed to me, I'm going to use that T as part of the declaration of methods, return types, or as arguments that I'm passing to something. So here, what this says is, for a stack, I want to be able to push something. I want to be able to push something onto my stack. The definition or the declaration of this interface doesn't need to know or care what that type actually is. It just says, if you implement this interface, you can push something onto this thing. The pop operation here says, I want to have a pop operation here. And what I want to be able to say is, if you implement or use this interface, you're going to be able to pop something off of the stack, and its type is going to be whatever type you told me when you declared an instance of this thing. I'm going to pop over to my main function here, my main class, my main file, and I want to take a look at a declaration of an instance of this property or the stack interface here. So on line 12, what I've got here is I'm creating an instance of this interface that's called strings. I'm passing to the stack interface the type string here. So what that effectively means is that everywhere that there's a T in this interface declaration, I'm going to replace it with string here. So when I call push with an instance of this type here on this variable that's called strings, it's going to expect me to put a string into that method. When I call pop, it's going to return something of type string. If I put something else in that type declaration, it's going to be whatever I put in there that's going to change the way that these methods are declared for that interface. I've created a couple of instances of this. So these are classes that implement that stack interface. And I'm going to continue to use the T here because what I'm saying is I still don't know what the type is for this array stack type. This is not an instance of this class. I'm just declaring all the implementation of the interface that's defined in the stack type. So I still don't know what that is. And when I'm making methods in this implementation, I'm still going to use this type T here. I don't know and I don't care what I'm going to have internally in this stack. All I know is that when I declare an instance of this stack, that's when I'm going to specify the type, and that's when all these methods are actually going to have types attached to them. So if I go back to main here, what this effectively says is I've got this stack of strings. I'm passing the string as a type to the declaration of this interface. And when I call something like push here, it's expecting an instance of a string object to be pushed onto that. When I call pop here, it's going to return to me an instance of a string that I can print out. If I change this to some other type, it's going to expect the same sort of idea. If I change this type to be something like, and I'll put this on the next line, a final stack, and what I've declared in this other model package here is a 3D printer and some layers. If I have a stack of layers here, now this array stack implementation is going to have methods that are implemented for the layer type itself. It doesn't need to know or care what it is in the actual implementation that I've got. I just tell it, this is the type that I'm going to use for this thing. Yeah.
Can we make a stack of objects multiple types?
Can you make a stack of objects that has multiple types? So that's a great question. I'm going to say one is don't. You can, yes, but I'm going to say don't. And the reason I'm going to say that is that if you make a stack that has multiple types in it, and I'm going to delete these angle brackets here. If I make a stack without specifying what the type is, or alternatively, if I make a stack that has type object as the parameter that I'm passing here. So I'm going to ask you, because I'm not sure where you're at from 1020. I'm going to make a statement, and I want you all to like agree with thumbs up or disagree with thumbs down. Object is the parent class of everything. Okay, so we're all on the same page about that. And that kind of means that I can replace anything with an object. If I declare a variable as object, it can be any class on the other side of the assignment operator. If I do this, what I've effectively done here is now I've made a stack that can take anything. I can put strings in it. So I can say layers dot push new integer 42. I can say layers dot push. I might have to cast this to object before I'm allowed to do it. Actually, what is it saying here? Oh, I'm not allowed to do new integer. Integer dot of value of. Yes, that's what I want. I can say hello. I can say layers dot push. Gosh, I don't know. What's your favorite object type? This is a stupid question. What's your favorite class in Java? What's your favorite class in Java? Scanner. Great. Yes, thank you. A new scanner. Now this needs to have something in it. System.in. Now this stack has anything in it. But the problem is, I don't know what's in it. Like, I know what's in it because I can see what I've pushed onto it. But if I'm getting user inputs and like putting random stuff in it, now it's my responsibility to figure out what those things are. And so the goal here of saying I want this specifically to be of type layer, when I change this back to layers, it's a compile time error. I'm not allowed to add these other kinds of things to this stack. And it makes the code that's going to work with that stack simpler later. Yeah.
When we define what we're putting in our stack, we know exactly what it is. However, don't we lose that as soon as we then assign it to key for stack.out? Because now we don't know the string is scanners, anything like that.
What we're saying with generics ultimately is I want to make something that contains some other type, but I don't need to know or care what that other type is. So my stack implementation, my stack interface here, and then both of my implementations of my stack type, they internally do not need to know or care what kinds of things are actually being put in them until compile time. So when I write the code and I specify the type and the variable that I'm declaring, that's when they know what kind it is. That means that my implementation of an ArrayList stack that has this type T, it can really only assume that the thing that's being put inside of it is an object. That's all it can really assume. I can't use methods in pop here, for example, that will rely on it being a string. I can't use methods in pop that rely on it being a number, but that's fine. That's because I don't really want to rely on any of that stuff. I want to separate my implementation of this collection from things that it actually has inside of it. Did I answer your question? Did I understand it correctly? Okay. Okay. Yeah.
Just a bit confusing what actually the capital T is. Can you just use object type of words?
Capital T is meant there to represent the word type. You can't use the word object because that's an actual class type in Java. Actually, I don't know. Yeah, it's not gonna be very happy if I put the word object in here, I don't think. It's not gonna be very happy about this, I think. Gosh, now I'm just gonna prove myself wrong. However, I'd argue that this is quite confusing to use the word object here to represent that. It compiles. It's confusing to use the word object here because now it's actually a type that's well known among people who code in Java. I think maybe to answer your question, the T here is my choice of a string. If I want to use the word type here to represent this instead of T, yes, you can. It's an arbitrary identifier that you're using for the type name that you're passing into this thing. Any other questions? Yeah.
So it's an arbitrary thing for one specific type, right?
So I could have T, K, Y if I wanted. I could put commas in here to specify multiple types for something. And maybe this is part of your question that you were asking before. If I have a container type that's going to contain 3 different things and I want them to be all different types, I could put commas in this type declaration. I'm going to say if you're doing something like that, you're probably going too far. You're probably going too far. The one case where this is valuable and where it is used commonly in Java is the map types, where you have a key and a value type. The key has its own type, the value has its own type. So if you're using something like a hash map, that's where you might have seen something like this before. Okay, all right, awesome. I'm going to comment this out. Because this is preventing me from compiling right now. And what I want to do with this right now is I kind of want to take a look at the idea of ownership of what we've got in the composition relationship of the array stack type here specifically. So I'm going to take a quick look at array stack. Array stack here, this is a class that is composed of an array of elements. Here I'm using the object type because I can't have a generic array. That's something that I'm not allowed to have in Java, so I have to actually use the object type to represent this. But the relationship that the class instances of ArrayStack have with this property elements is that it is composed of. When an instance of this variable type goes out of scope, then it implies that I won't be able to reach these elements anymore. They're effectively gone. So the relationship here that we've got between an array stack and elements is that we've got this composition relationship between these two things. I'm going to go to my main class here. And what I'm going to do is put a breakpoint right there. I want to have a breakpoint set when I start pushing things onto the stack. And I'm going to start debugging this. At the bottom, what I've got here is this nice pane that's showing me what the value of things are right now. And importantly for our discussion right now, it's also showing this thing here that I'm going to call an address. But the other way that we can think about this is that this is a unique identifier for that specific instance of this class. So I've got this variable that's called strings that I declared as a stack of strings. It has this at 758. If I were to make another instance of this, call new array stack somewhere else, there would be something like 760 after that to show that these are two separate instances of that class. As I push things onto this stack, what we're going to see is that we're passing ownership of these string instances to that instance of the array stack. So in Java, when I'm putting these string literals in here, I am creating instances of the string class, and I'm passing them to the strings class that I implemented here, the array stack, and then the strings instance of that. As I go through and I pop those things off, I'm effectively asking for them back. I want you to give me back control of ownership of this thing. So as I step over this, I'm getting ownership of that string, I'm printing it out, and then I'm discarding it. I'm allowing it to be garbage collected because it's gone out of scope once we reach the end of that loop and we repeat this thing over again. So as I step over this, I'm popping elements off of that strings array, and now the strings array is going to be empty at that point. Whoops. I need to bring my mouse to class instead of using my touchpad because it doesn't work very well. The other thing that we've got is I've got this method that's called fill stack with numbers. And what fill stack with numbers here takes is an integer. It's a class instance of integer because I want to pass it an instance of an integer class. And what I want to do inside of this is I have a stack of numbers that is going to use that array stack type. It is composed of the numbers that are being put onto the stack. And when we leave this method, what we're effectively saying is I cannot reach those things anymore. They have been destroyed because I can't actually touch them anymore. I can't get to them. All of those instances are gone. However, our main function, or our main class, sorry, has passed an instance of this integer type to this method. So it's retaining its own reference to that thing. So I'm going to step into here, this method. And what we can see is that we've been passed this number, integer at 759 here, and its value is 42. If I pop back up on the stack of method calls here, we can still see that the best number here is integer at 759. These are physically the same thing that we're referring to in both of these cases. As I step over this and I initialize this and I start pushing these numbers onto my stack, I'm adding stuff to the stack. And then when I get to, I'm going to go backwards, stop. I'm going to put a breakpoint right here. I'm going to debug this again. I'm going to continue to that point. I'm going to step over this. 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so now we're on the last iteration of this. Our numbers array is filled with these integers. They're all integer at something, so they're all instances of this integer type. And then as soon as this goes out of scope, we cannot access those additional integers. So our composition relationship here is effectively saying they have been destroyed because I cannot reach them anymore after this. That said, I'm still able to see this integer at 759. I still have a reference to this in my main method. So as I go back up to my main method, the main method still has integer at 759, but everything else that was in that composition relationship is now unreachable and I can't get to it anymore. So in practice, I'm using the word destroyed here when we're talking about this composition relationship, but effectively what I'm trying to say by that is when this variable goes out of scope, I can't get to the things that it's composed of. It has this composition relationship with. Aggregation relationships are going to be more like many different things have references to these things, or they are at the top layer of something here. All right. Okay, I'm going to hit play here. I'm going to allow that to continue. And I'm going to pause for a moment, take a sip of coffee, and make sure that we're all doing okay.
So we did add some numbers to the stack after 42.
Yes.
So when we refactor to the main, what if we pop 42?
We can't pop anything off the stack because the stack has gone out of scope. It has effectively been destroyed at that point. Once we're back in the main method, because the stack that we were filling here is local to fill stack with numbers. So once we leave this method, that stack that's called numbers, we can't access it anymore. It has been destroyed at that point and we can't touch it anymore.
Also, another question. We always use integer with the big I. We can't use primitive.
So that's a great question. If you are using generics like this, you must use uppercase versions, uppercase class versions of all the primitive types. You cannot pass int here. It's a compile time error to pass int. You must use that. So if you want it to be something like a double, you have to use uppercase D double. If you want it to be a Boolean, it has to be uppercase B Boolean. If you want it to be a character, it has to be uppercase C character. Yeah. Yeah.
So potentially we can store that somewhere else and continue to have access to those. It's like an implementation issue that the composition thing is broken. So we have made the instances like fields of another class, for example.
So I'm going to try to restate your question to make sure I understand it. Just let me know if I'm misinterpreting. The question is ultimately on pop. So here is my implementation of pop. In pop, I'm effectively returning a reference to the thing that I'm popping off of the stack, and I'm effectively giving control of that thing to somebody else at that point. Once I do that, I am no longer composed of that thing. The stack is no longer composed of the thing that I've just removed from the stack itself. I've given ownership of it to somebody else. What they do with it, maybe they make it a composition of their own object that they're creating at that point, but what they do with it is irrelevant to me. It's not going to get destroyed necessarily when I get destroyed because I don't have ownership of it anymore, and it's somebody else's responsibility to deal with. So it doesn't really break the composition relationship here. It's more like I'm removing this from myself and letting somebody else deal with it, so that when I am destroyed or garbage collected, I'm only going to worry about the things that are actually in me right now. Yeah. Okay, everybody please stand up for a moment. We'll put our arms in the air like this. Thank you. Okay, good. Now we'll put our arms down. Yes, thank you. I love having this power over a room of people to just do whatever I ask them to do. You can all sit down now. Thank you. Okay. Okay, so this repository is posted. There are lots of comments in here describing some of the ideas that we were talking about. I'm very happy to talk more with you about this on the course forums or during office hours, but I do want to move on to something else at this point. So what I want to move on to at this point is the idea of using toString for output. This is a very common pattern that you were doing in Comp 1020. I create an instance of this class, and then I do system.out.println. Sometimes I'll put the .toString, sometimes I don't because it's implied when I append this to a string, it just calls toString for me. However you were doing it before, it doesn't really matter. The question I really want to ask is, should I use this approach for printing stuff out for the person that's actually using my program here? So I say to my mom and to my dad, hey, look, here's this really cool program that I've written, run it. Should these lines of code exist for them to interact with it, for them to see what is in my internal state of this thing? And like I said, previously, my answer to this is probably not no. This is probably not something that you want to be doing going forward. But why? Why? I think this is a good question. Why? Why not? Like, why should I not do this thing? There are two compelling reasons that I have for you right now. One is you should be adhering to the single responsibility principle. Do one thing and do that one thing well. I believe that I've told you probably enough times that you're sick of me hearing it at this point that a class should not be responsible for printing itself. toString and then building up a string that describes what this output looks like is effectively the same thing as just doing printing in the class itself. A class should not be responsible for knowing about how it's displayed to other things. It shouldn't have to worry about how it's going to be displayed to somebody that's typing commands at the console, and it shouldn't have to worry about how it's going to be displayed when you show it in a window on a screen. It shouldn't have to worry about that. If your class is responsible for managing data, it should manage data. Yes?
Kind of an abstract question. If there is a case where you would want to use toString like exclusively internally, maybe
I'm not sure I can imagine a situation where you'd want to use toString for data manipulation internally.
maybe not data manipulation.
I am going to give you one example where I think this is a valuable thing to do. So just hold for a second, and I might be answering your question in a moment. Okay. The other reason, and this is the more realistic reason that I want to bring to your attention, is this idea of localization and internationalization. This idea of localization and internationalization is basically making sure that your software works for other people. Internationalization is kind of like taking the strings that you would otherwise hard code in English and being able to change that string. I'm not going to ask anyone to identify themselves, but many people in this room, I believe, have parents and friends and siblings where English is not their first language, where English is not a language that they maybe even know. There are lots of people in this world that do not speak English, surprisingly to many English speakers. We want to make software that works for other people. And if I'm hard coding English words in my toString that I'm then printing out, I've hard coded English words in my toString that I'm now printing out. For me to make that work for somebody else that doesn't speak English as a first language is going to be quite challenging. If my class doesn't have to do that in the first place, then it's something else's responsibility to figure out what those strings are supposed to be. Localization is an idea that where it's not just language and terms that we're using, but things like the way that time is displayed might be different in different areas of the world. The way that money is displayed is definitely displayed differently in different areas of the world. The way that text is printed is sometimes printed differently in different areas of the world. Some are left to right, some are right to left. Localization is the idea of changing that stuff around. Internationalization is very much about being able to change the strings that are being printed based on who is working with this thing. That said, and I believe this might be the answer to your question, toString can be useful for us. toString can be useful for somebody that we're working with. toString can be useful for things like debugging information, printing out log messages that some other developer is going to be reading, printing out, this is what this object looked like just before I was about to crash, is something that you want to communicate to somebody else on your dev team. Your parents don't care. Your parents are never going to see that message, so it doesn't matter really that it's hard-coded in an English string, assuming that you are working on an English-speaking team. So in short, my statement here is that part of the reason why I'm trying to make these printer classes for each of these domain model objects is that I want to be able to get to the point of being able to do things like change the English strings when it's being run, as opposed to having to worry about what my toString looks like when I'm starting with this stuff. Does this answer your question? Okay, awesome. Okay. All right. So I'm just asserting this to you. I'm asserting this to you, and I hope that you're taking the message that I'm trying to share with this. The very last thing that I want to introduce to you today is this idea of design by contract. Design by contract is a strategy. This is an idea that we're going to apply to the code that we're writing, and it's an idea that is going to be applied with the goal of preventing programming errors. The purpose of design by contract is very much about working with other dev people, working with other people who know how to do programming, working with other people that are actually using the code that we're working with from a technical perspective. And so we're going to be working with this idea from a technical perspective. This is an idea. This is not actual points. The point is thinking about this idea of design by contract. I want to really strongly emphasize that this is not meant to be a tool for preventing somebody that's using your code, your parents, your friends, your family, from inputting invalid data. That's not what this is about. They overlap a lot. The things that your parents can type in that are invalid are still invalid from a programmer's perspective. But we're talking about two different things here. The word null is going to show up in this conversation. What we're doing with design by contract ultimately is writing some code that's going to encode our assumptions. When we're saying things about a class, in 1020, we're using words like integer, and we're using words like string, and we're using words like array list. What I've been asking you to do when we're starting to do domain modeling is let's actually try to put this into some kind of non-technical term for at least number types that represent what are the valid values of this thing. These are the assumptions that I have about this type, and I'm trying to put that into the domain model that I've got. We're going to start to take those ideas and then actually enforce these ideas with code, and that's what we're going to start to do with design by contract. I want to emphasize that this is for developers. This is for people that are doing programming. The kinds of programming errors that we can work with are things like syntax errors, and syntax errors, that's a solved problem because our compiler helps us with that. These are things like unintentionally using invalid data. This is where we're going to be looking at, and I'm going to invoke the word null here. Oh my gosh, everybody please raise their hand and then I'll ask the question. Now I'm going to command you, raise your hands please. Everybody please raise your hands. I have seen the words null pointer exception on my screen. Good, everybody has seen that. I guarantee it. Everyone has absolutely seen that. We don't mean to do that. Like, we don't want to see null pointer exception, but we've all seen the words null pointer exception show up on our screen. The other case that we've seen, and I won't ask you all to put your hands up because I can't guarantee that you've seen this, but array index out of bounds exception. Yes, that's another common one. Index bounds or range errors, and this is often going to be an off by one issue. You don't mean to do this. This just happens as your code is executing, as your code is running. Design by contract is a tool that's meant to try and prevent those exceptions from happening before you give your code to your parents. This is something that's meant to prevent this exceptional behavior before we get to giving it to somebody else. Just to clarify what the idea of exceptions are for everybody, The idea of an exception here, or an exceptional state, is that we're getting to a point in our code's execution where we really cannot proceed because something has gone wrong about what our internal state is. Null pointer exceptions mean the variable that you're trying to refer to is null. I can't proceed because I don't know what I'm supposed to do after that. We've got file-related issues. I can't proceed because I can't actually open the file that you've asked me to open. And then we've got off by 1 or division by 0 things, so number-related things like arithmetic exception and array index out of bounds exception. I don't know what it means to look at index element, array index element -1 from Java's perspective. So I'm just going to stop. I'm going to stop going. I'm not going to continue with any of the stuff that we're proceeding with. Generally, these are coming from violations of the assumptions that we've made about the state of our application. And there are 3 places where these assumptions can be violated. One is where we're starting to process data, but we haven't actually done it. These are somebody's giving us inputs that we're going to work with. And I'm going to use the word preconditions to describe this. Another is after I have finished processing data, I've made changes to the internal state of something, and I'm going to give it back to you. But I made a mistake, and I've put a null inside of the object that I'm returning to you, or I'm going to return null to you because that's the state that I'm in my recursion, for example. This is called a post condition, and I'm going to use this word to describe this idea, something that I want to verify after execution. The other is the state of an object throughout execution. And I don't mean this at every single statement, but I mean this kind of like before and after we make changes to something. The state of an object is going to be enforced by us using this idea of something called a class invariant. A class invariant here is really just a description of what we deem to be a valid state in our object. And again, this is from a technical perspective. I want to make sure that null is never present in my object. That is not a valid state for my object to be in. And if it is in that state, then something has gone wrong. Something's gone wrong either by me or the person that's passing information to me. Again, we're not protecting against our parents, and I will invite you all to look at your keyboards right now to try and find the null key that your parent would be able to type to actually put null into our code. Nobody's looking down. You all know the trick, so I think that's okay, yes. I want to build up some class invariants in the last couple of moments of class here. I'm going to pop over here. I really like using Mermaid in IntelliJ, but what I'm finding with using Mermaid in IntelliJ for the perspective of like presenting something to you is that the mermaid diagram becomes really, really small and it's impossible to see it. And so I want you all to be able to see this. I'm going to go through this. I'm going to mark up this mermaid diagram using a note on the class. And what I'm going to do is tell you. I'm going to tell you what all these things are. And then next class, I'm going to ask you to do the same thing for me. I'm going to ask you for feedback about what these invariant properties are for this class. So for today, I'm going to start on this trainer type. And then next class, I'm going to ask you the same kinds of questions about Pokemon below this. The class diagram that I'm working with here is what's in the 2450 Amon repository right now. So if you want to see this on your screen in a smaller format, that's where you can find that. The idea with trying to build up a class invariant here is that I want to go through and I want to make explicit statements about the properties of the class that I'm working with. The trainer class here has 4 properties. These are all things that are going to be instance variables in my class itself. I've got a team of Pokemon, I've got some set of items, I've got a name, and I've got a balance. I'm going to start changing these to be technical descriptions of what they actually are. A Pokemon collection for my team is actually a list. If you've played Pokemon before, you know that the one that shows up first is the one that actually gets put out first when you're playing it. There's an order to these things, and so I want to make sure that that's there. there are two properties about this that I'm going to share with you that must be true for an instance of trainer to be a valid instance of trainer. So I'm going to say note for trainer. And what I'm going to start writing for this is some invariant properties. Whoops. So I'm adding this note to this trainer class. The first thing I'm going to say is that a team of Pokemon must never be null. It must never be null. There must be an instance of a list. There must be an instance of some kind of list in that class instance for it to be valid. So I'm going to immediately say here that team does not equal null. I am using technical terms to describe this because I'm trying to communicate this to other people that are working with my software. Another thing, and this is me knowing about domain stuff in Pokemon that I'm going to share with you, every trainer must have one Pokemon. You cannot have 0 Pokemon as a trainer. You must have one Pokemon. So there are two properties about the team here that must be true for this to be valid. Team must not equal null, and team.length, or the number of things in this, must be greater than 0. I'm going to actually say this as greater than or equal to 1 to really specify what I mean by this. So in an instance of trainer, for it to be valid, I must have a non-null team, and I must have one Pokemon in there. There has to be a Pokemon in there. For items, I can say that items must not equal null. Domain knowledge of Pokemon, it doesn't matter if you have no items as a trainer, but you have to have something there that I can add to. When I go to the Pokemart and buy something from the Pokemart, I don't want to get null pointer exception. I want to just be able to add item to this Pokemon trainer instance. So the thing I'm going to say about this is that items must not equal null. Name here is something that is actually going to be a string. I'm going to change this type to list. I'm going to change this type to string. This is actually what I'm going to use internally here. A string in Java is an object. It's an instance thing that we can make an instance of. A name here must not equal null. I could initialize a variable with type string to be null. I do not want that to happen. At least when I give it back to somebody or when I get it from somebody, I don't want it to be null. I'm going to make an assertion that the name.size, and I might be mixing up my length and size here, so forgive me if I'm doing that with string and lists and whatever. The name.size must be greater than or equal to 1. You have to have a character in your name. I'm going to assert that your name must have one character in it for it to be valid here. The last thing I'm going to do with this is I'm going to say that we've got this money type that's balance. I'm going to say, I'm just going to represent this as an integer. In Pokemon, I don't know what the symbol actually is or means, but there's a symbol that means, like, people are doing it with their fingers right now, I think. Yeah, it's a symbol that represents money. I don't know what it is or means, but I'm going to represent that internally as an integer. I'm going to say that it's an integer, it's a primitive type, it can't be null because it's a primitive type, so I don't need to say that it should not be equal to null. However, integers, as we all know, can be negative. And so now I'm going to say that the balance that I have, and you can't go into debt in Pokemon. There's no, like, loan sharks that you can borrow money from. It's not Animal, oh my God. Animal Crossing, yes. What is the name of the Animal Crossing? Tom Nook, yes. Tom Nook is like this loan shark. Animal Crossing is just the most wonderful game. It's delightful to play. It is so fun, but it just gives these weird ideas to children that you must take out a loan to get a house. And like you have to take out a loan to improve your house. And it really pushes you to take out a loan to improve your house. In Pokemon, you cannot go broke. Like you can have no money, but you can't have negative money. Just one moment, please. And so what I'm going to say here is that for this to be true, your balance must be greater than or equal to 0. It must always be greater than or equal to 0. And that means that when I do things like, I'm going to scroll down here for just a moment. When I do things like change balance here, I'm going to guarantee that it's never going to go below 0. I'm going to make that guarantee as part of this class invariant. So I will update this class diagram and share it with you in the repository for this project. And then what I'm going to ask you to do next class is to do the same exercise, but with Pokemon. So at this point, you should be able to design and use generic interfaces. You should be able to explain why toString is not an appropriate tool for displaying information to people. And you should be able to define the invariants and encapsulate